following is an explanation of example 5.5 off page 197. This problem works with Avogadro's law. Avogadro's law is much like Charles' law and Boyle's law in that we can only work with them when two of our variables remain constant. In this example, we are told that we have the same temperature and pressure, so we can make a pretty good guess that pressure as well as temperature must remain constant. Only when these two remain constant are we allowed to work with Avogadro's law. Avogadro's law, quite simply stated, is that the volume is directly dependent on the number of particles times some Avogadro's constant. What we can do is get that constant by itself by moving the n to the other side, and we get volume over the number of moles is equal to A. Now that A is the same at the beginning when we're working with oxygen gas as it is at the end when we're working with ozone. Because we are changing the composition, we do have to write a balanced equation. 3O2 gives us 2O3. If we have half a mole, 0.50 moles of O2 at the beginning, we need to figure out how much O3 we're going to have at the end. We do that with a simple conversion. Plug it in a calculator or do it in your head, and you get 0.33 moles of ozone. Now, as always, we've got two different times. We have one time where we're working with oxygen gas, the other time we're working with ozone. Our volume when working with oxygen gas is 12.2 liters, and our number of moles when working with oxygen gas is half a mole. Our volume when working with O3 is unknown, and our number of moles we determined to be 0.33 moles. As with before, all we need to do is set V over N equal to itself, plug in our values, 12.2 divided by 0.5 equals question mark over 0.33. Solve for that volume, that question mark volume, and you get a volume equal to 8.1 liters. Now, Avogadro's law, when compared with Charles' law and Boyle's law, is relatively infrequently used. We hardly ever see it, and the reason we hardly ever see it is because there are very few examples where we can just flip from one number of mole to another number of mole. There has to be an actual reaction. We tend to use these laws more of when we're talking about a balloon of one gas that's been heated or has been cooled or placed under a pressure, or a container is crushed. We tend not to use these kind of problems when we're working with reactions. We tend to use gas stoichiometry when we're doing reactions. That being said, if you ever find pressure and temperature being constant, you could look at Avogadro's law. Again, this is example 5.5 off of page 197.